Okay, so what I thought I would do is do a little video on confidence intervals. In our in the last case about this is sometimes we know the mean and the standard deviation of a population, and we want to kind of compare a sample to that. In this case, we have no information about the population. We don't know the mean, we don't know the standard deviation. What are we going to do? Well, we have to use our sample to make some kind of guess about the population. And look here, look, this is cute. In statistics, you can never be 100% certain, by the way. And there's Garfield sitting on the sofa, taking a look at tomorrow's weather. The high temperature will be between 40 below zero and 200 above. And Garfield says, this guy's never wrong. So we're going to do confidence intervals. We're not going to be quite that large in our estimation of what the temperature would be. Okay. Let's just say, for example, we have the example of male CNA student height. Let's say you wanted to know the average or the mean height for all students at CNA, all male students. There's a number out there that says, okay, all male students are this number, but we don't know. This would be considered the population parameter. Mu is equal to some height that we don't know. How can we get a reasonable guess for this population parameter? Anybody know how we get that reasonable guess? What's something we use to help us guess a population parameter? Well, we would use our sample statistic. Use sample statistic. And in this case, if we're looking at mu for the population, we're going to get a sample mean. And we're going to use this to kind of make a guess about this. We could use just this one number, but that's typically not what we do. Typically what we do is we do something called an interval. And if you know the word interval, it means we've got a low end and we've got a high end. The following is a confidence interval for the estimation of height of the population of CNA male students. It's a 95 CI. We'll get into what this means in a minute. It was created from a sample of 40 male students. So you went out, you got random sample, 40 male CNA students, measured all their height, took their shoes off, got the thing, put on your mask, whatever. And there's 3 different ways that you can write it. Method 1, and this method 1, and it depends on who your audience is and how you want to present it. This is broken up into 2 parts. The first part is what we call our point estimate, and in this case, it's the sample mean. So 175 centimeters. This is the sample mean, and of course, we know the sample mean is x bar. It's also called a point estimate. We say plus or minus because we're going to have one end is the minus and the other end is the plus. What is this 6.2 centimeters that we're adding on? This is called the margin of error. How much do we want to it's not how much we're off, but it's kind of like how much the mean is here, sample mean, and then we've got so much on this side and so much on this side, which is called the margin of error. Plus or minus MOE. And the margin of error is made up of a couple of things. What are those couple of things? Well, we'll get into it a little bit further on, but it's basically some kind of multiplier times the standard error. Remember our good old standard error? And what does this multiplier mean? What is that thing all about? Well, if you think about, remember our normal distribution curve, and we said 95% is about between -2 and 2. So for 95%, we're looking at about the number 2. If let's say we wanted to do 99.7, that would be, the multiplier would be 3. Those are different numbers that we're going to use, and that's going to come up in a minute. Method 2, notice here how I've got 168.8 centimeters is less than mu, which is also less than 181.2 centimeters. So we're saying that the population mean is somewhere in between these two numbers. Now, where did those two numbers come from? Aha, look up here. If I take 175 centimeters and I add 6.2, I add 6.2, I end up with 181.2 centimeters. And if I subtract it, then I end up with 168.8 centimeters. This gives me our kind of our interval, our range. We're saying, okay, well, we don't know for certain what the population mean is, but we're going to say 95% confidence, which we'll discuss in a second as well, that the mean is somewhere in between these two numbers. Now, maybe it's 170, maybe it was 175, 177, but we're saying, okay, it's somewhere in here. Method 3, you might see it written like this, and it's just you take your little brackets and you write the two numbers here. Method 1, Method 2, Method 3. Let's just say we had Method 3 written, okay? I want to know, how do I get back, let's say, to this format? What could I do to figure out what is my margin of error and what is my mean? Let's think about it. Well, we can figure out how long this interval is, and I'm going to get my calculator and just pause for a second. I think I'm going again. I should have known this, but anyway, what is this range of values? This range of values here is we take 181.2 and subtract 168.8, we end up with 12.4. Ooh, 12.4. Because we have 168 here and 181.2, how can we figure out if this is 12.4, what is our margin of error? Can you see something here? Yeah, all we got to do is divide it into two parts. This gives us our margin of error, 6.2 and 6.2. How can we figure out this middle number of 175? Well, we can add this on here and we'll get 175, or if we subtract it here, 175. And this way we can work backwards and we can figure out, if we've given this here, we can figure out what was our sample mean and what is the margin of error. Confidence levels. Okay. See this 95% up here that I said it was a 95% confidence interval? What does 95% mean? Basically, if you were to think of 95%, that's the same thing as saying 19 out of 20. And if you don't believe me, put it in your calculator, and 19 divided by 20 will give us 95%. Well, why would I write it like this? Basically means is that 19 out of every 20 confidence intervals that we create will cover the population mean. One time out of 20, it might not. See how here's the mean that exists. This is the population mean. This confidence interval, yep. This confidence interval, yep, yep, yep. This one isn't. So notice here it says a 95% confidence interval indicates that 19 out of 20 samples, 95% from the same population, will produce confidence intervals that contain the population parameter. Okay, so 19 out of 20 samples from the same population will cover it. Okay? We don't have to have 95%. We could also have a confidence level of 90%. And 90% would be 9 out of 10 samples will cover the population mean, will include the population mean. We could have 80%, 8 out of 10 of them. We could also have 99%, which is 99 out of 100, and so on. There's certain levels that we have, but I use 95 a lot because 95 is kind of a standard. And that's the introduction to confidence intervals.